Hi, welcome to the Shiko Math Lab Fun Probability Problems Solving Session. And today we're going to do a proof of some very basic probability rules. Those rules kind of make sense intuitively. So now let's see how can we formally prove it. So for this problem solving session, we're going to prove two things. Okay, so the first one is here, we talk about A and B are two events defined in this simple space. Now I want to prove A belong to B, then PA would be less than or equal to B. So the A is kind of intuitively obvious, but we're going to show you how to prove it. Then the B is the A intersect B complement is equal to the PA minus P probability of the A intersect B. All right, okay, let's go ahead and get started. Okay, so our first proof we're going to prove is if this symbol is like included, that means it is a part of the B, all right? So then we want to show probability of the A is less than or equal to probability of the B. All right. So this is kind of intuitively truth here, but how do I prove it? Okay. So now in here, the first things here. Let's take a look from the Venn diagram, and maybe we can get a better idea. So here, this is my B. Okay. So this is my B, and the inside, this is A here, right? Because we say A is a part of the B here. Okay, so now if A is a part of the B, I can define the B will be equal to A, right? So A is here, right? So it will be A union, okay, B intersect A complement, right? So will be this yellow region union this light blue regions, right? So this light blue region is the B intersect the A complement here. All right. Okay, so now I will say the probability of the B will be equal to probability of the A plus probability of the B intersect A complement. Why? Okay, the reason why I can do this is because A and B intersect A complement are mutually exclusive. Right, so this yellow region and this light blue region, they are mutually exclusive. So that's why my addition law will just be the PB equal to the PA plus P the intersect the BAs here. Okay, so now for here, I know the probability B by, okay, so probability intersect B intersect the AC. And this number, because this is a probability, so it's always greater than or equal to 0. So the reason why this is true, we say this is because this is probability axiom. Okay, because here, right? So now if I move here, I say PB minus PA going to be equal to the probability B intersect A complement. But this one is always greater than equal to 0. So I can find is the PB minus PA is going to be greater than equal to 0. So here. Then that's how do I prove? So I know the PB greater than equal to PA. Or, you can write is the PA is less than equal to PB here. All right. So the first part is it's pretty straightforward, and even is intuitively, it's like obvious, right? But then when we try to prove it, we do need to use the law we know about it. All right, so let's take a look at the second part here. Okay, so the second ones here, they want us to prove the the A intersect the B complement equal to the PA minus P, the probability A intersect B here. Okay, so let's write down the problem. So this is a part B here. So we want to see the things we want to prove here is A intersect B complement is equal to the PA minus PA intersect B here. Okay, so in order to do these problems here, and let's try to take a look at two events, right? So this is my events A, this is my events B. All right, so the A intersect B. Okay, so now I'm looking at the A's here, right? So A is equal to this region. This is the blue region, right? So what is this region? This is A intersect B, correct? All right, so this is A intersect B, and the union, which regions here? A union this region, the yellow regions here, right? So what is the yellow region here? The yellow region is the A intersect B complement, right? So these ones here, the B complements is everything outside, right? Outside the B here, right? Then intersect A. That's why I give you the yellow region here. Okay, so now I can put the probability notation again. So the PA is equal to the P, the A intersect B, plus P, the A intersect B complement. So from here to here is the same reason, because A intersect B and A intersect B complement. So what happens here? They are mutually exclusive, right? As long as they are mutually exclusive, so by addition law, you just add these two pieces here, okay? And now that's what is the PA. So now the problems here, we want to find the A intersect the B complement. Then I just minus the P, the A intersect B. So it's PA minus A intersect B is equal to the A intersect the B complement. And that's what we finished the proof here. So it is a pretty short proof, and so I will recommend the typical when you try to prove some probability, properties. The Venn diagram sometimes is always very helpful here. Well, I hope you enjoyed this short proof here. All right, so you have a good day, and nice to talk to you today, and looking forward to work with you for our next problems here. Okay, bye. Have a good day. Bye-bye.